Still loading.
Next speaker is Dr. James Church about first steps with Wireshark. It says Dr. James Church is an associate professor at computer science and information technology at Austin Peay State University since 2016.
Hey, let's go pee.
Let's go pee. Let's go. Yeah, let's go pee. But not all at the same time. He completed his PhD in computer science from the University of Mississippi in 2014. In 2017, he started and continues to lead ASPU coding camps, which teach computer literacy, online safety, and programming skills to younger children, and over 2,000 children have been through the program. In addition to teaching, he has been the program chair for the ACM Mid-Southeast Conference since 2019. He has authored one book, Learning Haskell Data Analysis, and one popular Amazon Alexa game that has been played over 20,000 times, titled Hunt the Yeti. He enjoys traveling with his wife, Michelle Allen, and playing with their adorable pet iguana, Khan. Everyone, please welcome Dr. James Church.
Thank you so much for that rousing introduction. And thank you so much to the students of Austin Peay State University for being here. I did not promote this at all to my students at APSU, and a lot of them showed up, and it was just as much a surprise to them as it was a surprise to me that a lot of my students would be here. So thank you so much, everyone, for showing up. Let's get to, I really wanted to do I really wanted to do some Wireshark examples today on the hotel Wi-Fi, and that may or may not work in today's talk. How many of you already have a really good familiarity with Wireshark? Okay, about half the room, and so the other half, welcome. This is going to be our first steps in Wireshark. So there we go, first steps in Wireshark, James Church. By the way, this is what my slide decks look like for all of my classes. They are beautiful text on a white background, nothing exciting. You're not going to see any pictures of my slide deck. That's just how I work. A little bit about me, a quick story time, why learn Wireshark, and things I want to do in this particular talk, and then we're going to end it out with a demonstration. So,
can you make the font smaller?
I will. No, I can't. All right, a little. Oh, is it too small?
No, not at all.
Oh, okay, all right. So a little bit about me. Again, currently an associate professor of computer science at Austin Peay State University. There is my link in bio link, beacons.ai/JCChurch. You can email me at Dr. James Church. Yes, that is my email address. It's really great that my last name is also a top-level domain. That means I can get james.church, and then I can put the prefix at the beginning, and it works out great. All right, so standard disclaimer, the opinions expressed in this talk are my own and not necessarily those of my employer. I'd like to keep my job. All right, second standard disclaimer. Oh, we're having two of them in this talk. It's going to be one of those. Okay, great. This is an educational talk. The things that you learn can be used for good or evil. Please use this knowledge for good. I don't want to see any of you get in trouble and then say, oh, but I saw this one guy do it at a con. No, please don't do that. All right. Okay, so why this talk? Why right now? I was asked to teach a networking course with only 2 weeks' notice before the start of our semester. We had a very competent networking professor at Austin Peay State University, and then 2 weeks before the semester began, he goes, I'm out, bye. And then my department chair comes around to my office and says, Dr. Church, congratulations, you're our newest networking professor. And I went, okay. The last time I had taught a networking class was about 5 years ago. I am definitely not a networking expert, but I play one on TV in front of a room full of students. I can talk about the aspects of networking, and I could read the book and repeat the book back to them. That's pretty much what I'm doing in my classes right now. And because I had to learn Wireshark so quickly for my classes this semester, I thought, well, let's just do it for Freaknik this year. I think that'll be a fun talk to do. So that everyone can get familiar with this incredibly useful tool for studying your particular network. All right, story time. Story time. I'm a grad student at the University of Mississippi. This was back during the 2000 aughts. I'm sitting in the coffee shop. I've got Wireshark running on my computer, and I've set the filter on Wireshark to be HTTP, and I'm just watching the links come in. Just like you can do that. Set your laptop to be promiscuous mode. Read in all the packets. Set it to just HTTP. To just that top level link, and you can read all of the links that come in on that particular in that particular Wi-Fi network. That's what I was doing at the time. You can't do that as much nowadays because of what? HTTPS. 99.9% of all the top 10,000 websites on the internet are now running HTTPS. Back 10, 15 years ago, you could do this in a coffee shop and read everyone's traffic. Oh, it was such a wonderful time. It was such a wonderful time. And it really made this talk a whole lot more interesting. If we could go back in time a little bit, Wireshark gave you a lot more information back then. But I see a friend of mine come in the door. His name was Arvinder. He was from Punjab, India, and he was a Sikh. And one of the characteristics about Sikhs is that they wear the turban. Anyway, I see my friend. He was a member of the computer science department at Ole Miss. He walks in the door. He doesn't see me. He gets in line for a coffee. He still doesn't see me. He buys his coffee. Still hasn't seen me. Sits over on the other side of the coffee shop. I see him open up his laptop. Still hasn't seen me. And I'm watching my screen. And now I start seeing links related to Punjab, India start appearing on my screen. I grab the last 5 links of websites that he goes to. I email them back to Arvinder and say, hey, Arvinder, here's the last 5 websites you've been to. And then I see him cocks his head to the side a little bit, comes back up, closes his laptop, joins me from across the room. He knows the risk of surfing unencrypted Wi-Fi in a coffee shop. And he came over, we had a great time. But that should motivate you a little bit in learning a little bit about Wireshark, because this is a fantastic tool for learning about just what happens on your network. Oh, and okay, there's my slide. It begins in a coffee shop. So why learn Wireshark? So here's my bullet point list, by the way. If you see text on the screen, more than likely it was created by ChatGPT last night. Because I was like, I don't know what to say. So we're going to ask Chat, and so these were the things that ChatGPT said that you should know about Wireshark. Not me talking. You should learn it for troubleshooting network issues. If there is a bottleneck on your particular network, Wireshark will definitely help you diagnose these issues. If you realize that this can help you improve your network performance. If you realize that one part of your networking closet is performing really well and the other side of your networking closet is performing poorly and you aren't sure why, pull out Wireshark. This is a great tool for studying that. Study your network security. You can hop on Wireshark. You can look at all of the protocols that are flying through your network, and if there's any unsafe protocols that you really don't want running on your network, you can talk to people and say, hey, stop running that particular piece of software on my network. And you can just learn a thing or two about networking. Every single time I turn on Wireshark, I learn a little bit something new about what it's like to use the internet and what I believe is mankind's greatest invention, the internet. For a while it was USB Type-C, but no, it's still the internet. Back up to number 1 in my mind. All right, so there we go. Why learn Wireshark? So audience participation time. How many of you are software engineers? A smattering, a smattering. How many of you are network security professionals? Way more in the room, network security professionals. How many of you are over 40 and still on a path of self-discovery? Way more people in the room, hands go up. All right, there we go. So I expected a chunk of you in the room to say you were software engineers. I expected a chunk of you in the room to say you were network security professionals. And I didn't expect much overlap at all between those two camps. I really, I think I saw a few people raise their hands for both. But it wasn't supposed to be many. So here is the OSI model of the internet. We can talk about each of these layers. If you take a basic networking class, you're going to be confronted with this list of layers. You got your physical layer. That is the the physical wires and the chips that lead towards, that connect routers along the internet. You've got the data link layer that consists of your MAC addresses that are on the wires and chips that help identify the hardware manufacturers that build these particular hardware components. You've got the network layer. That is where a network decides whether we're going to use IPv4 or IPv6. You've got your transport layer. This is where you pick the higher level protocol, usually TCP versus UDP for transporting data across the internet. You've got the session layer. This is for your highest level protocols. This is going to be things for things like TLS, HTTPS, HTTP, Telnet, SSH. Your higher level protocols are going to exist at the session layer. At the presentation layer, this is where your software engineers will decide whether or not to encrypt your data, how that data should be presented. Should we use JSON? Should we use YAML? And then you've got the application layer, and that's where you actually work with the user interface on your particular, in your particular bit of software. So you can see that we're going from very high level abstract software in the application layer all the way to the physical layer, which is the physical wires connecting the entire internet.
You're missing layer 0 where all the problems actually happen.
Yeah, layer 0 is where all the problems actually happen. What is customarily considered layer 8? Humans are layer 8. So layer 0, the mythical layer where all the problems happen, and then there's layer 8 where all of the other problems happen. None of the problems exist on this slide. All right. Your typical software engineer lives here. They like to live at the application layer, they like to live at the presentation layer, and they like to live at the session layer. The application layer and the presentation layer is how you build the user interface, and then how you build how you model the data that you're preparing to send out over the internet. The session layer is where you determine the high-level protocol that will be used to transmit that data. It's usually going to be an HTTP-S packet or some other method of transporting data over the internet. All right, so your typical software engineer knows this area very, very well. Your typical data admin lives here. The physical layer, the data link layer, the network layer, they know whether their networks are capable of running IPv4 versus IPv6. They know about the hardware manufacturers that have built all of the routers in their network closet. They know about how to distinguish the MAC addresses on those hardwares. They know how to physically plug in a Cat5 or a Cat6 cable into a router. So there you go. What's missing? Nobody lives here. Very few experts live in here. What are you doing if you are in layer 4?
You're an old man at Berkeley.
Yeah, you're an old man at Berkeley. You are bridging the two worlds. This is where your TCP and your UDP packets live. TCP just works. It's how old is TCP?
1987.
Yeah, 1981. 1981 is TCP. RFC 793. That is TCP. What about UDP? And I honestly don't have that one off the top of my head. So if you tell me,
Got lost along the way.
yeah. So what?
So it got lost along
Yeah, that joke got lost along the way anyway. TCP is known as the reliable, somewhat slower, somewhat more top-heavy network protocol. UDP is often called fire and forget because it's just spraying packets everywhere. And depending on the application that you use, TCP, UDP. All right, and where does Wireshark live? Because that's kind of the basis of today's talk. Wireshark, I like to think of Wireshark living at layers 2 through 5, because it's not really going to tell you about the physical wires, but it will tell you about MAC addresses inside of the data link layer.
Well, I mean, it's all the layers because it gives you the binary data all the way to the application.
It will give you all the layers. Well, it's not going to tell you about your application.
And
Well, sometimes it will.
like HTTP, it'll tell you what the request was.
Will it tell you what browser you're using?
If you've got to extend it, if you've got to minus capital A.
the capital A. But where I think Wireshark lives is really these 4 layers, the data link layer all the way down to the session layer, because the session layer is going to be where your highest level protocol lives, down to the data link layer, which is your MAC addresses. All right, so things I really want to do in this particular talk. I want to capture some packets on Wireshark and then just see what the Wireshark looks like. We're going to explore the Wireshark interface. I want to talk about some of my favorite features. I want to make some quick buttons on my interface and talk about what they do. I want to talk statistics for a little bit, and then I want to snoop some telnet traffic. Woo! Woo! Snooping telnet traffic. That is classic. As long as it is your traffic, it is perfectly legal. You can snoop your traffic all day long, and that's what I intend to do today. Just so you can get an idea of what it's like to snoop some telnet traffic, because I think that's the most fun. Let's get Wireshark going, and yeah, you can see I've got my telnet address up there. Don't go to that just yet. So let's capture without saving. Let's see if we can get some data coming in. And do I just need to surf some websites real quick? Let's just go on here. Let's go to APSU. Let's see if that works. There we go. Cool. Yay. We're going to Austin Peay State University. Represent. Amazon. You'll notice that every time I go to a website, I'll go back to APSU. There's a little lock in the corner up on the URL bar up there. What does that lock mean?
HTTPS.
Yeah, we're using HTTPS. There's npr.org, and you see that little lock in the corner? That means we're using HTTPS. If I swap over to Wireshark, ooh. All right, oh, there we go. We got quite a bit of packets coming in. I'm sorry, I had a filter turned on at the beginning. And if I scroll down to the very bottom of my list of packets that have come in, you can see that I'm up to about 23,000 packets just in the short time that I've had Wireshark turned on, and I said start up a new packet search. And you can see that more are coming in while I've got this going here. All right.
And that's on the hotel Wi-Fi?
No, this is on my personal Wi-Fi that's connected to the hotspot on my phone.
Gotcha.
Yeah, because I did not want the Wi-Fi to go down in the middle of my talk. This is kind of Wi-Fi dependent talk. Let's stop this capture packet. I think 24,000 packets is enough in order to talk about what's going on behind the scenes. We can do this first column here that just tells us the packet number since I hit start searching packets, that's the packet number. It starts off at 1 and then ends with whatever packet number you've collected. This is the overall time since I started collecting packets. That's that second column. So I've been collecting packets for 104 seconds, so almost 2 minutes worth of packets to get 24,000 packets. Here we have the source IP address, and then we have the destination IP address. Here we have the protocol. We have the length of that particular packet here, and then we just have some generic info about that little packet. Now, what I like to do is talk about the interface at first. So up here, that first panel up at the top, that's going to be your packet view, just to look at all of the packets that have coming in. Down here, you have the packet detail view, so I can select any one of these packets. And then I can zoom in on, ooh, that's a SYN-ACK packet. So we can talk about SYN-ACK packets for a little bit. You can see that that is a TCP packet that I have selected because it says right there, TCP. TCP stands for Transmission Control Protocol, right at 100 seconds. And then what I can do is I can look at the details of the packet over in the detail view, and then I can look at the payload information right there in the bottom corner. Great, sounds good. And you can look at the payload information. What does that payload information look like?
Garbage.
It just looks like garbage. It really just looks like garbage. That's all you can really tell about that. What I like about this So in TCP, if I may, I would like to deep dive into TCP for a little bit. How does TCP connect? How does one computer connect to another computer using TCP?
Three-way handshake.
Yeah, everyone knows about the three-way handshake. What's the first step in the three-way handshake?
SYN.
The SYN. Well, what do you know? There's the SYN packet right there, and you can see that it's connecting from my phone to a computer off in the distance. And then what does that second computer do?
Hack.
It does what's called the SYN-ACK packet. It's both a SYN and an ACK. And you'll notice that the very next packet on my list, right there is my SYN-ACK packet. And you can even see right there, it says SYN and ACK. I don't know how well that shows up on the overhead projector. And then and then what is the third part of the three-way handshake?
Hack.
Yeah, and just an ACK. And then there we go. It's SYN and then SYN-ACK, and then the third step is an ACK. And you'll notice that this particular ACK packet goes from my computer back to the destination computer. That completes the three-way handshake, and we've formed a TCP connection, and that becomes a TCP stream by which data can now be transmitted between the two computers. A TCP is what's called I just blanked on the term. It's the term whenever two computers can talk back and forth with each other.
A session.
Full duplex. It's full duplex. Full duplex means, it is a session. You're absolutely right there. But a full duplex connection means that data can be transmitted back and forth over the same wire. Now, one thing that I really appreciate about Wireshark is that it looks at all of this information, and then it starts building its own meta information on top of the information that comes in. For example, if I go down to, if I select right there, I don't know how, let me get the magnifier up. Because I really doubt y'all can see much of that.
Oh, wow. I forgot that existed.
Yeah, the magnifier is great. So there we go, the magnifier. You can see that I've got selected there IP protocol version 4. Where is that in the OSI model layers? Yeah, you're right, layer 3. It's layer 3. You're absolutely right. And this is where it's decided whether you want to use IP version 4 or IP version 6. Most of the internet today still uses IPv version 4. But I can scroll down a little bit. Where are the port numbers located in the overall networking stack? The port numbers, the source port and the destination port for your packet information is in the transmission control protocol port. There's your TCP port diagram. It's embedded in that layer of the TCP port. And what I really appreciate about Wireshark is that every time it's going to take those four numbers. It's going to take the source IP address, the destination IP address, the source port number, and the destination port number, and it's going to take those four values and add them to a table, and then it's going to stick on a number 1. And then the next time it sees a different combination of those four values, it's going to add it to a table and stick on a number 2. And those are called the stream numbers. And right now, you can see that I am on stream index 373, which means this is in just the short minute and a half that I was surfing the web, I accumulated 373 streams while working on my computer. And what's neat, I mean, there's a lot of great information there. I'm going to stay on this packet because I think there's a lot of good information here. I'm going to go up to this filter section, and I'm going to type in tcp.stream, and then I can type in that particular number, 373. There we go. There needs to be 2 equal signs there, double equals, tcp.stream 373, and now I can focus just on that one stream of that particular combination of IP addresses and port numbers. And so I can hone in just on that stream. And so we filter just to that particular combination. I think that is a really cool feature of Wireshark. And so that's something that is a benefit to using this particular software. Okay, let's keep going. I want to talk more about things that you find inside of the packet. So the first thing in a TCP packet is the SYN, and then the SYNAC, and then the ACK. That's the three-way handshake. I can see that there were 2 more packets sent. One that was 54,000 bytes. Or no, I'm sorry, that was 54 bytes. Another 54 bytes. And then whenever it ends, you kind of need a FIN packet. Oh, I see those are both FIN packets. And then there's our ACK packet. So we are acknowledging the finishing of that particular stream. It was a really short stream, only 6 packets. If I come over here, let's see, I'm going to select this one. What does time to live mean in networking?
Number of hops between switches.
Yeah, the number of hops between switches. That's exactly right. So what happens whenever a packet is transferred from one router to the next? Every single time it crosses through another router, that time to live setting drops by 1. So where is it? What's that number going to be the next time it hits another router?
127.
127, and then 128. And then, well, one of 2 things is going to happen. I can subtract by 1. Yes!
Yeah. APSU, man.
APSU, credit to our math department. So one of 2 things is going to happen whenever that number, eventually, that packet will either reach its destination or it will hit 0, and then whatever router the packet hits 0 on, that router just stops acknowledging that packet and it doesn't go on to its destination. How many hops does it take to get around the world? If I were to pick out any server in the world, what would be the maximum number of hops it could take to get to that location? Think about the most distant remote computer on Earth. And where would that computer be? Antarctica, maybe? Would it? If we're using a satellite, we go up. We figure out how to get to the satellite uplink point. We go to the satellite, then we come back down. That's 2 hops between wherever we are and Antarctica. Most places, it's going to be less than 50 hops. And in order to get anywhere in the world, and I really think if you have a time to live more than 50, you're working on something really, really interesting. You'll notice here that the time to live says 128. The vast majority of packet routing protocols set that time to live at something that is a log-based 2 number, or a power of 2 number. So 2, 4, 6, 8, 16, 32, Nintendo 64, 128. Something in that sequence. So what does this tell you that the time to live number is at 128? It's probably fresh because it's one of those log-based 2 numbers. If I were to go to the very next packet on my list, you'll notice that the time to live is 49. So because that's not a log-based 2 number, that's probably an indication that that helps us kind of figure out how many hops it took to get from our particular source to our destination. So more than likely, what is the smallest power of 2 number greater than 49? 64. 64. So it's probably starting off at 64. That's my guess. 64 minus 49 is 15. It probably took 15 hops to get from whatever server I'm looking at in order to get to this particular destination. And again, all I'm doing is just looking through all of the information provided by Wireshark. The other thing that I like is if you, I'm going to go up here to Edit and Preferences. And we are going to go to, I'm getting thrown off by my own mouse pointer. Sorry, y'all. We're going to go to the Layout section. And one thing I like about the Layout section is that there's all of these layouts that you can pick. So they all have exactly 3 squares on them, 1, 2, and 3. But you can decide what you want to put in each of the 3 panes. One thing I like to do is for whatever my 3rd pane is in the bottom corner, so this corner right there, I like to put my packet diagram packet. And you're going to see my packet diagram change. So I can actually scroll through, and if you have studied what TCP packets look like, and you know what these packet diagrams look like, then you can, if you know you want to look for something in particular in a particular packet, you can scroll through here, find anything you want. For example, I want to look at the TCP control protocol flags. Well, I go to TCP control protocol, I click on flags, and it jumps over to that part in this pane over here, and I can grab that very easily. One of my favorite little tricks in Wireshark is grabbing that. What is the width of a packet diagram? The width of, so all of these packet diagrams that were designed way back in the day, you've got the Ethernet packet diagram, the IP4, the TCP, they all have the same width.
4 bytes.
4 bytes, right. It's exactly 32 bits, or 4 bytes. You'll notice that we've got source port here and destination ports there. If this is 4 bytes wide, then you got 2 bytes for one, you got 2 bytes for the other. And down here, it looks like I've got that same half area, so that's less than 2 bytes. The flags area of a TCP packet is 12 bits. And because this is both a SYN and an ACK, I can come over here and I can look at the binary flags. There is the SYN flag. You'll notice it's set to 1. I've got my mouse pointer on it right there. And then the acknowledgement packet, that's a 1. I can look at that right there. And so I can find the middle handshake in the three-way handshake. Okay. Now, one of the other features that I love about Wireshark, oh, that mouse pointer is really throwing me off, is the colorized packet list. Oop, nope, maybe that was the wrong one. Color rules. There we go. There's our color rules. So these are the rules behind Wireshark and how it determines what packet gets what color behind the scenes. So I can tell that an ACK packet is always red, and I can say a SYN packet is always green. And there's always these bad TCP packets. For example, there's a packet that had a lot of bad content behind it. And from here, I can create my own customizations for every single packet once you learn the filtering language behind the scenes. But what I'm going to do is I'm going to take that filter line and I'm going to hit Control-C on my keyboard. Basically, I'm going to copy that real quick. And now, what I'm going to do is what I could do is I could literally just paste that up here. And this will give me all of my bad packets that happened during my transmission. This is a great tool for just studying what has gone wrong on a network, because packets are sometimes going to time out. Packets are sometimes going to get sent more than once. Packets are going to have checksum errors. And so it's good to study that to see what percentage of your packets are coming through incorrectly. And it's going to happen a little bit to some effect. Let's get that magnifier out of the way. But over here, I want to talk about these quick buttons. And what I can do is I can click that little plus button right there, and I can add that line as a filter, and I can give this a name. So there you go. It automatically took that filter line and added it to this filter line. And then it says, give this a label. And I'm going to say, bad packets. There we go. And now, anytime I want to look at bad packets, I can now click on that, and it will automatically bring up my bad packets anytime I want. So this is so Wireshark is a tool that really lends itself to high flexibility in order to help you figure out the problems that are existing on your particular network. I've got a few of these set up here. My mystery website. I forgot what I was doing at that time. I'm going to delete that one. I want to look at just my DHCP packets. Okay, I had no DHCP packets. What about my HTTP packets? I had a few HTTP packets in here. What was I doing on HTTP? I really don't remember. I was looking, that looks like it was the start screen of Firefox, detectportal.firefox.com. You can see that right there. That data comes through just fine. Let me start capturing packets again. Where can I find that?
Right there.
Okay, there's the user agent. So it will tell me the application. So if you really want to, you can push that all the way to the top level, application level. But that's getting harder and harder nowadays thanks to HTTPS. Yeah. But there you go. You can see that I was running Mozilla 5.0 in order to get that to work. I want to go back to my slide deck for a little bit. So I said that 99.9% of the top 10,000 websites on the internet use HTTPS, and that is the secure encrypted web traffic. But there's a few major websites that still don't use HTTPS, and so I thought I would highlight those on this website. You'll notice at the top of this list, Baidu. I noticed that of this particular list, three of the top links that I picked out were Chinese websites. And I was like, why are these major Chinese websites not using HTTPS? And then I didn't think much longer after that. So there you go. If you go to Baidu, and if I'm just going to click that link, we're going to copy that. We're going to go back to our. Let me start capturing again. Do you want to continue without saving? Yes. All right. We're going to continue without saving. We're going to start a fresh packet search. I'm going to go back to Firefox, and let's go to Baidu. There we go. I'm now on the Baidu website. Let's go to another website. What was another one on my list? This is a Chinese e-commerce site. One that I thought was a really big one, University of Washington. Let's check that out. Like that. That's weird that University of Washington still uses HTTP. Washington.edu. So there's the front page of the University of Washington website, and if you stare at the corner up there, you can see that there's that little lock icon, but it's got the red bar through it. What's that mean? It is, we are not using SSL, connection not secure. And what that means is that any data that I transmit back and forth between University of Washington and my computer gets sent in the clear. So let's see here, if I can find University of Washington in my list. I bet I can find it pretty quick. What was that? Nope. I thought it would just do HTTP and DNS. All right, there we go. Let's scroll through here until we find, that may be it right there. Yep, that's it. So you can see how University of Washington is getting sent in the clear over HTTP. Why is this important?
Because if all the CAs go down, their website will still work.
Yeah, if all the certificate authorities go down, their website will still work. Hey, that's a good one. But if I'm sending data back and forth between the University of Washington, there could be someone sitting in a coffee shop running Wireshark who sees all of that information getting sent in the clear. Let's do one more. I thought this was interesting. NGIX.org. That is a software project. Anyone know what NGIX is?
Nginx. It's Apache, but lightweight.
Russian.
This is a Russian. This is a Russian web server that only supports HTTP. No wonder they're running on an insecure network that only supports HTTP. There is no HTTPS.
Nginx supports TLS.
Oh, it does?
Oh yeah, it's like one of the best web servers there is. It's just the same there. The office is in Russia.
I thought.
It's like one of the best. Like it and Apache are neck and neck.
Okay.
It's fast, right? Fast Apache.
It should. Okay.
Oh wow.
I didn't realize that, but for whatever reason, okay, I stand corrected. They do support TLS. For whatever reason, their main website is not a secure website.
Once again, if the CAs go down,
Their website will still go up. All right. So there was my, I talked about making some buttons on the interface. I talked about my favorite features of Wireshark. One of my favorite features of Wireshark is down here in Wireshark, ooh, let me get Wireshark back up. Down here there in the bottom corner of the screen, there is a profile button. I just have a profile for James Church and for me, and then I customize this to the point where I really like it. There's one for Bluetooth, Classic, Default, and then you can make as many profiles as you want on here. And I encourage you to make a profile that really meets your needs whenever you are working with Wireshark. Really great tool. Okay, all right. You ready for the last part of this talk? Yay! Let's snoop some telnet traffic. So I've got a telnet server, and if you were on your computer, hopefully you didn't go to this telnet site and start hacking away at it.
We're about to find out.
We're about to find out, absolutely. There we go. There we go. All right, so let's get telnet going. Telnet. Oh, by the way, am I still collecting traffic? Because if I don't, I'm going to have to do this again. All right, good. I'm still collecting traffic. In fact, I'm going to stop this just to make sure that you can see this from a fresh start. And we're going to continue without saving. There we go. There's my telnet traffic, and you can see it's asking for my login. All right. Oh, what's my login to this particular server? Obviously, JC Church. And then what's my password? Oh, I'm not telling you.
JC Church is awesome.
There we go. I'm not telling you what my password to my telnet server is. Of course not. Why would I do that?
Let's snoop it.
But well, now I'm into my telnet server. Let's say I'm going to work, and my workplace requires me to go to work on a telnet server. And if your work is telling you to go to work on a telnet server, please convince them to go to something encrypted, such as SSH protocol. But here we're on telnet. So this is a server that I set up earlier. I can start up Python 3. I can for I in no while true print hello world.
Oh, God.
There we go. There we go. We get hello world infinitely on the screen. Great. But what happens behind the scenes inside of Telnet whenever we look at this in Wireshark? So I'm going to swap this over. I'm going to set the filter to the Telnet, and you're going to see all of my Telnet traffic appear inside of Wireshark. Sounds good? So let's just start going through here. And ooh, where is my display? There we go. You can see the initial communication of the telnet traffic down here. There we go. That's cool. Let's go on to the next packet. All right. There's the data for the next packet. Nothing really useful. There's the data for the next packet. Again, nothing really useful. Oh, this is 138 bytes. Ooh, we got some information. Display, Grundy, screen, 256 color. All right, we're setting up for a 256 color display. Let's go to the next packet. Okay, nothing really useful. Let's go to the next packet. Nothing really useful. Next packet. Again, nothing really useful. Next packet. Nothing useful. Next packet. Oh, wait, here we go. We got something. We got something. Debian GNU Linux 1.1. There's the port. There's the IP address, and then it says login. Oh, what's the computer waiting on whenever it says login on the screen? The username. And what was my username?
JC Church.
JC Church. There we go. If I scroll down here, I want you to pay attention to the very last character in the packet. Oh, what do you know? It's a J. Guess what? Oh, and if I go to the next packet, the last digit in that packet, also a J. That was conveniently that was the first letter in my name. Man, I'm gonna have to. One moment. I'm going to.
Change name.
No. I'm gonna set this up to be parallel. That way I can look at this packet back and forth. All right, I lost my place. Oh, look, you can actually see all the hello worlds I printed on the screen. There was a lot. I got to find that packet again. All right, there we go. Found it. I'm going to scrunch this up. Oh, I can't scrunch this up. How do I get rid of this middle pane?
Alt F4.
That is great. All right, so there we go. There's the J, and then that's the J that I am sending to the server, and the next packet also has a J at the end. That's the J getting received from the server because I'm sending it a J, and then it's showing that J back out onto the screen. The next one is a C. That's the C I'm sending to the server, and then it's sending a C back. My name is JC Church. Oh, so there's the C. That's the C I'm sending to the server. There's the C that I'm sending back. We could go through my entire name. There's the H. That's the H I send. There's the H I send back. I'm just going through these packets one at a time. The next letter is a U. There's the U. Again, it's getting sent in clear text. There's the U that's getting sent back. The next letter is going to be an R. I'm going to skip to the next one. There's a C, and if I skip down one more, there's the H. All right, so I have finished off my name, and then I hit the Enter key. And what is the binary code for Enter? Yeah, it's 13. It's 13, which is what letter of the hexadecimal alphabet? D. And sure enough, there's a D that shows up in the hexadecimal right there. That's the symbol of me hitting the Enter key on the keyboard. We're going to come back, and then lo and behold, the very next packet says password. Oh, you're actually going to read my password now. What happens whenever you type in a password in Telnet? Whenever you pass in a username, you'll actually see your username appear. But what happens when you type in your password?
You get
You send
registered.
a letter and it sends an asterisk back.
There we go. Well, in Telnet, just nothing happens.
Yeah.
Just there's no echo at all. So there we go. Oh, there's the first letter, H. And you'll notice that I'm not skipping packets now. We're going one packet after another. There's U, N, H-U-N. I don't know what my password is. T, what could it be? Hunt, oh wait, are you already, H-U-N-T-E, Hunter, Hunter, H-U-N-T-E-R, and then 2. So there we go, Hunter2, that's my password to my Telnet server. Yes, that's your password too?
Yeah.
Oh wow, I didn't know we had the same password. That's great, we should be best friends. But there you go. The thing that I want you to remember about especially some of these older protocols, Telnet, HTTP, all of that information is getting sent 100% in the clear. Someone dedicated on Wireshark can can pull that information straight out of the air and then start snooping through your particular traffic. So even though y'all couldn't see my password because there was no echo, we could still jump into Wireshark and still recover that just fine. And then we can scroll down and I can find where I started up. At some point, yeah, there we go. There's all the hello worlds I sent getting transmitted back. So thank you everyone. Thank you so much, everyone. That concludes my talk. Oh, wait a second. I've got a file in here called Run Me. Did one of y'all add that?
Do it.
Do it.
Look at it first.
Do it.
Who did that?
Don't do it.
Who did that?
Do it. Flash do it. Run his route.
Lipstick.
We're just going to run it. All right, everyone.
That's nice.
Yeah, everyone thank Ben the Meek and all of our volunteers for an awesome treatment. I'll see you in 2024. All right, let's get that magnifier turned off so you can actually see the message. There we go. That's how I wanted to end it. Thank you so much, everyone, for hearing my talk. Is it? Yeah, there you go. I ended on time. My clock way down here is 10 minutes off. Cool. Everyone, again, thank you. Yeah, any questions about Wireshark?
Can you real quick go on a deep dive to the advanced filters of TCP dump?
Real quick.
Real quick, just go into TCP dump. Now, there are way more features of Wireshark that come with Wireshark. Oh, by the way, I need to turn off the telnet port on this server like right now.
Open telnet port, you should get it.
Yeah, one moment, y'all. I am going to. Oh, where was that sticky note with the?
Just closed it.
I just closed it. There we go. All right. We're gonna copy that. I'm gonna get in real quick. Hopefully, I can be faster than whoever's on a terminal. There we go. And then close telnet port. Great. Good. Now I can feel a little bit better. I shut down the telnet port. No one can.
Oh, were you faster?
I'll find out later. Because I'm sure there is someone in the room who could potentially take over that server in faster typing speed than me.
We'll be ready next year.
Oh yeah, you'll definitely be ready next year. I hope you are. That's kind of things I love doing in my classes. I'll have open servers up and just see how many students can get in and have fun with a server in my classes. Let's go to CMD and let's.
We're on the OS.
There we go. Program files, CD, tab. Wireshark, dir. There's a bunch of tools here that are available to you, not in addition to the main Wireshark executable.
T-shirt.
The one that I wanted to highlight was, I think it was, dir exe. There we go. Dump cap.
That's the opposite of the PCAP.
Oh, what's the flag that tells you all of your interfaces inside of dump cap? Oh yeah, Command I. That's what I typed. I thought. There's one that actually will list your interfaces.
I'm thinking TCP dump is minus L. Or minus capital.
Yep. Oh, capital D. There we go. Capital D. So there's all of the network-enabled devices on my computer. And then what I can do is I can select one. I can select my Wi-Fi. I'll just copy that. And then I can say dump cap I, and then I can paste that there. And now I can start capturing packets from the command line. And that will get stored directly to my computer. There you go. And it's getting stored to that local file, users, JC Church, app data, local temp, Wireshark, and it comes up with a random file name. But I've collected 160 packets. Control C out of this, and now I can go pull up those packets in Wireshark and then study them. Sometimes that's easier to do than just getting into the Wireshark interface and trying to fight with the interface. You just do everything from the command line.
How do you follow the streams from the right-click menu?
How do I follow the streams?
Yeah, you were trying to do like a filter to do it.
I didn't talk about statistics. I skipped that. I was going to show you all the statistics menus inside of Wireshark. You had a question, sir?
I was going to comment on the command line. There's actually a bunch of other sniffers besides Wireshark that work really well from remote sessions. You know, Sniffit is one of my favorite, and then there's purpose-driven ones like SNGRET for doing VoIP traffic and things like that. They're tuned up for command line sniffing and packet capture.
Fantastic. I am most familiar with the tools that work on the Linux systems, and then of course just the tools you see here inside of the Wireshark Windows folder. But there you go, everyone. Thank you so much. Let's end with a fortune. No. Oh, right. Fortune. There we go. Few things are harder to put up with than the annoyance of a good example. There you go, Mark Twain. All right, everyone. I appreciate you.